So I want to just go over this one first. So def word count, and that's going to take in a string. I'm going to call that string text because it's probably going to be a lot of text. So I'm just going to give it the name text. Okay. Now it returns a dictionary. And I'm going to call this counts. Returns a dictionary, and we already know from the problem definition, having read it once, it's going to do word count. So I'm going to call it counts, and I'm going to return it at the end. And obviously, that's not enough for me to do that, but it figures out, okay, hey, this gets me some stuff already correct on the auto test, right? Um, Now the way and what I plan on doing also is showing you for the next one how these things work, because that's also a very interesting thing. So def word count is equal to text, count is equal to dictionary. So we have an empty dictionary. And now what we need to do is that we need to say, given this text, figure out how many times each word is in the string. Now, as we discussed on as we discussed on previous in the Thursday lecture, the space is the most common character in the English language because it separates out all of the words. Every word will have a space in between it. So if I want to know what the words are, what I'm going to do is I'm going to say text is equal to text dot lower, since it said convert all lower text to lowercase. I'm generally going to tell you can assume all your text is lowercase and that you don't have to worry about punctuation. And then split at spaces. So words is equal to text dot split. And we're going to split at spaces, it says, to more easily compared. So sweet, sweet Briar should give you sweet 2, Briar 1. A string with no words should return an empty dictionary. And that's fine because we'll do this. We'll try to split it. We're going to get an empty list. And then what we're going to do is say for each word in words, what are we going to do? We are going to iterate over this and we are going to say, okay, if word in counts, that means we've seen it before. We'll do something there in a second. I'm just trying to show you don't have to do it the same way I did the first time on Thursday. If the word is in our counts, if we've seen it before, we're going to mark down that we've done that. Otherwise, we say counts. We've not seen it before, so we've seen it once now. Count of that word is equal to 1. Make sense to everybody? If I've seen it before, then I'm going to increment my count, which I'll do in a second. Otherwise, I haven't seen it before, so I'm going to say, oh, well, I've seen it once now, so I've set that equal to once time. Here, all you have to do is very similar. Counts of that word is equal to the number of times I've already seen that word, counts of that word, plus 1. Right? And that gets you a word count. Let's see, none. Local variable word. Oh, words. There we go. And the correct count for, okay, so an empty string here. Okay, so apparently it counts their empty string. So let's go ahead and just simply say if len of if length of text, we don't really won't need this on an exam or anything. If length of text equals 0, return counts. There we go. Being a bit of a stickler here. Okay. Now this one is the one that gives a lot of students pain, mainly because there's some testing around it that stinks. So let's go ahead and try it, and then we'll look at and then I'm going to show you. Yeah. Okay. Create a function called translate that extracts a string in a dictionary and returns a string, which is the translation of the original string. I've supplied an example string in dictionary. I've supplied an example string in dictionary. This return string would be diaduit Python Mickline. I assume that's Gaelic. If the word isn't in the dictionary, return the original word. Okay. So, hello, Python students are fun. Yeah. Oh, yeah, it's Gaelic. Okay. Def translate. And the idea here is that given a string in a dictionary, so I'm going to call it text and dictionary, for we're going to go ahead and do words is equal to text dot split again on the space to get our words for word in words. And the idea here is that we want to return a new string. So let's call it translation is equal to an empty string. And we'll return it at the end. Return translation. That will give us our answer. Translation will be our answer. Return gives us our answer back so that it can be used by something else. Printing it is useful for a computer. Sorry, it's useful for us, humans, but not so useful for computers when we want to pass things between functions. So here, for word in words, what are we going to do? We are going to say, hey, let's take this word and translation is equal to is plus equals to something. So let's say it's a word split text word and words. So let's go ahead and call it Gaelic, not Gaelic, because Gaelic is just simply this translated word. Because why not? Translated word is equal to dictionary word. And then what we're going to do is we're going to add our translated word in. Now, there's some issues with this, as we're about to see. Okay, translation. Okay, input should return word, none, error, output. Oh, that's very useful there. Okay, so translated word. What did I fail on? Okay, so this is part of the so actual def translate. Good. Okay, translation. Let's go ahead and print out what our translation is. Our text and our print text, print translation so we can see what we're doing. Input gives me word. Okay, that's cool. Error output. Okay, right. Oh, okay, yeah. So the next part is the part where I knew I would have to mess up. I was just wasn't sure that that was what was going to come on. The other bit that it says is that I've supplied an example string in dictionary that return string. If the word isn't in the dictionary, return the original word. So if word not in dictionary, very easy kind of check there, makes sense in English. Then we're going to say translated word is equal to word. Else, in fact, that rubs me the wrong way. So what I'm going to do is actually I'm going to set up translated word to be default, and then I'll say if word in dictionary. If it is in the dictionary, then we will get the translation instead. And that's what that tested is that, hey, it was testing, hey, we give you a here, I'll go ahead and show you dictionary. So the first test they did, whoops, I don't need colons right now. And then a print. So it's testing this by calling this multiple times. The first time it did the test, it gave us the word input, and input translates to word. And then the other one, it gives us output and the same dictionary. Input translates to word. And our input was the word output. Sorry, our text was the word output and saying, okay, since that wasn't in the dictionary, we shouldn't translate it. So that's why we get output as our output there. So now we get this other one, cannot concatenate string and int objects. And this is an annoying one because I know what's going on here. And that's just a bad test on the programmer side. I'm sorry, on the test designer side. And what it is that it's translating something into a string. Sorry, it's translating something into an integer, and then when we try to concatenate that integer, it gets us into issues. Here, like the test it gives is 1, 2, 3, 4, 5, 6, and then here's the dictionary 1, 2, 3, 4, 5, 6. And the issue it gives us is it gives us 1, 2, 3, 4, 5, 6 as our output. But the issue was that was trying to concatenate these things as integers, and that won't work. Now, we failed this output because it should be separated by spaces. So fine, let's go ahead and do that. Right? Words get separated by spaces. That makes sense. And then, yeah, we've added that in, but now we've fence posted. So we've got one too many spaces at the end. I'll take off that space. And there we go. And now if we actually run it on this problem, it actually will show translate string English Gaelic. And there we go. Of course, doing translation isn't necessarily this simple. Like translating from one language to another isn't this simple because this only really works if you can do a one-to-one translation from word to word. Languages don't work like that. For instance, a lot of English for instance, the grammatical structure of English is subject, verb, object. I kicked the ball. I being the subject, kicked the ball. But some other languages, like Japanese and German, they will be subject, object, verb. I, ball, did what? Kicked. And I know that may seem confusing and nonsensical to people who are English speakers like myself, but on the flip side, this way seems nonsensical to the people who are coming from subject object verb languages. So it's not necessarily as easy as one thing or the other. So I will share this code. But I wanted to just kind of go over that dictionary for with you. Those kind of problems. Okay. Dictionaries are going to be are pretty good tools, and that the reason I wanted to bring up the translation one is I'm I extended the time on the hurricane tracker. And the Hawaiian pronunciation one, I just want to kind of talk about that for a bit in case your TAs haven't gotten to it yet. This one's very interesting. This one, I like it, and I think it's going to be our last real homework before we start going into extra credit, before other things start becoming extra credit, and also we start talking about our final project. I plan on starting to talk about final projects next week, but if you have ideas for final projects, feel free to talk about them with me sooner. Because if you can figure out what you want to do, you can just skip coming to the proposal day, and we can just check you off then. So, um, so you're going to be using your dictionaries to do the Hawaiian word pronouncer. This was done by Kendall Bingham, and I adapted it for this class. So Hawaiian words are pretty intimidating, but they are pretty awesome. So, for instance, words like humu humu nuku nuku apua, they, as he says, look like someone's fallen asleep at the keyboard. But that's a real Hawaiian word. Is actually the Hawaiian state fish, the humu humu nuku nuku apua. Um, it's the reef triggerfish. Hawaiian name, Humu Humu Nuku Nuku Apua. The triggerfish with a snout like a pig. Um, now, um, the language is very simple. Hawaiian, as language goes, is very simple. Only 12 characters as opposed to the 26 that we use in English. 5 vowels, 7 consonants. We are going to write a program that allows a user to enter Hawaiian word. This is the objective. Enter Hawaiian word. Get the pronunciation of that word or words as output. So, for instance, if we give him Humu Humu Nuku Nuku Apua, you will get Humu Humu Nuku Nuku Apu A A. Okay? Now, Hawaiian has 12 valid characters. A, E, I, O, U, the 5 vowels. Very convenient that we use the same valid vowels you're used to. And then the consonants P, K, H, L, M, N, W. We're going to look at these now and the way these sound and work. So the consonants are super easy because the only thing that is different is the W. Okay, so all your P, K, H, L, M's, they are just like you would do in English. However, W's can be pronounced as V's or W's. And the only thing you have to worry about, in other words, think about a W being pronounced as W unless it's after an I or E, in which case it's a V sound. This is such a exception to the rule. I would make it the very last thing you program. Okay? It's that easy to add in. Vowels are very straightforward for the most part. A is ah. E sounds like eh. So Austin, Austin, Austin. A is ah. E is eh, egg, or a, eh. Okay. I gives the E sound, B. Okay. So O gives an O sound. U gives an oo sound. Ooh. Okay. So the catch to this is double vowels. Okay. And this is true for a lot of languages. AI gives us I. So E gives us I. A gives us I as well. O gives us ow. Wait, why does E give us I? Okay. So it's a bit of linguistic fun here. Okay. Why does A and I give us I? Well, think about it for a second. Let's just simply think about it. E. A E. 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 I. It gets once you start using on E, eventually the sound will blend and you get a single sound, which is why we get I as I. So I, this is also ow, ow, a, ew, ew. But we've got a list here. You don't need me to pronounce them all over. So we've got words like K. So this would be K key. Ke key. So this is the test. This is actually the test string I will give you for most of your assignments to see if this is working. KEI will give you if you do it incorrectly, then I'm going to get Keiki. Okay? But what it should be is Keiki. Maui should give me Maui. Okay? So um so here's the way your example output should look, right? Given invalid characters, it's going to yell at me. If I give it aloha, it's going to tell me aloha is pronounced aloha. If you want to enter another word, yes, no, yeah, Y, yes, and O, and instead I try putting in another word, it's going to just repeat and say, hey, give me a valid input. Uh, so next it puts in kakahiaka, kakahiaka, and it asks me for another word, mahalo. Yes. Ekomomai. And it keeps telling me until I get to, so here you can see the way that these input outputs work. Okay. Now, oh, this is why I haven't come in today. I feel all gross. Yeah, because it just keeps sneezing like that. Honestly, it's just a cold. I don't have COVID. I don't have the strep. I don't have the flu because I don't have a fever. Just got congestion, a sore throat, and feel tired. And occasionally I sneeze like a maniac. Um, so let's go ahead and boot up idle for a second to kind of outline this for you, okay? Okay. Now, the big thing that this class I'm trying to get across to you is, thank you, is how do we organize our thoughts, right? How do we organize this problem? Okay. So first things first, I'm going to go ahead and save this. Save as, and I'm going to go to desktop and create a Hawaii file. Okay, and we have um basically let's just kind of just go and organize from the top down. That's generally the way I try to see it. And the goal here is to look at tasks and stop thinking of them like they're ginormous, impossible tasks. Instead, we want to look at them as a big task that can be broken down into smaller tasks. We'll call our big task main. And we'll just call it at the end. Main is going to need to do some stuff. First, main is going to need to get some input, some word or some text as its input. Let's go with, again, keiki, right? We'll replace that with input for right now, but honestly, putting in input feels like it slows everything down right now. Then we have to basically, but we need to get our text, okay? Or it might be, or the text might be something else I want to test, like I want to test an invalid input, right? Never just test on in that on invalid stuff, right? Or sorry, just never just test on what you think the user is going to give you. So maybe something like that. Okay. So we have two things we need to do. The first thing we have to do is we have to validate that this is good input. Okay. And then the second thing I have to do is pronounce it. And then what I'm going to do is I'm going to ask them again and again if they want to do this. So I'm going to have to put this in a loop of some kind. So, but let's just assume that's one word for right now. Okay. So validate. Validate, what that's going to do is that we are going to def validate takes in some text and says, hey, is this made up of only valid characters? Is this actually something I can translate? Now I'm going to be lazy for right now and just simply say return true. Yes, everything is valid Hawaiian characters. Hawaiian can do everything and pronounce everything, right? Obviously not, because that would make a very uninteresting program. But now I can actually like use it and test it, even if it's wrong, right? Knowing that it's wrong, I can say stuff like while not validate text, right? Then the user needs to give me a good input again, right? Input. Let's go ahead and just put in the input right now. Input something like enter Hawaiian. How is it? Wait. What did I told you I am very tired. Hawaiian word to pronounce. Okay, enter Hawaiian word to pronounce. Okay, while not validate text, text is equal to input pronounce text. So while it's not a valid Hawaiian word, what we're going to do is we will just simply say it's wrong. And right now I'm going to just simply create a BS rule, like if text, if Z in text, right? Obviously we need to do a bit more than that. But this is just, I'm going to plan on erasing this as soon as possible, but this will just simply test, hey, do I have this going on? Oh, and now we need to go and actually share the entire screen. Share screen. And what we'll do is we will set this over here. Options, configure idle, so that now we can actually see my text. There we go. So what we'll do is we will once again run this. Enter a Hawaiian word to pronounce. Z, aloha. And now it's going to tell me we didn't create the function pronounce. So def pronounce, which is going to do the other big task, which is given a word, pronounce it for us. Or some text. Pronounce this text. Output is equal to an empty string to begin with. And then what we're going to do is we're going to go through it somehow. We assume letter by letter, but it's a bit trickier than that. Return output. And then we can say, print. How do I spell that? Yeah, pronunciation. Pronunciation is equal to pronounce.text. And then print. Text is pronounced pronunciation. And so now we can run this and we get how to enter a Hawaiian word to pronounce. I'll put in aloha and it'll say aloha is pronounced, and we don't get an answer because we don't have an answer yet, right? But that's fine. Okay. And then what you'll want to do is put this in another loop to see if, to keep asking, hey, do you want to do this? Keep doing this or not? Okay. Next, what we're going to do is talk about how do we do each of these things. Okay. Now, this one is, I'll actually start with the harder one, pronounce. Now, typically you would think, okay, what I'm going to do is I'm going to see you'll typically think something like this. And this is wrong, so don't copy it down, okay? It's completely wrong. Don't copy it down. It doesn't even begin with a for loop, okay? But you think for loop, for letter in text. And then what I'm going to do here is I'm going to do something like this. If letter it equals H or letter equal P, right? All the consonants, right? then we just simply add that onto the output. Output plus equals the letter. Okay, right. And then if the letter, oh, right, we could just do it like this. Right. You might think to yourself. Consonants. Again, that's not how you spell it because I am exhausted. Consonants is equal to, and then what we'll do is we'll just have a string of all the consonants, right? Okay. And the consonants in Hawaiian are P, K, H, L, M, N, W. M, N, W. And actually, technically, we'll be using apostrophe as well, but whatever. Okay. We'll call it a consonant if basically we get the same, if we throw it in, right? And we get the same thing out. P gives us P, K gives us K, H will give us H, right, in our output. Okay. Vowels, right? Our vowels are equal to A, E, I, O, U. Okay. Also, so we can now do this as if letter in consonants. So I'm basically speed running you through your first hour here of coding, first hour and a half of this, because I want you to not run headfirst into this part and bang your head against the wall. I want you to already see me bang your head against the wall so that you don't do this. Sounds violent. Okay. Anyway, if letter in vowels, okay. Oof. Well, if the letters in vowels, we know that if letter equals A, then that should be an A equals, not A equals out, but output plus equals ah. And now, boop, boop. What we'll do is we will Control C, Control V, Control V, Control V, Control V, Control V. Again, you should be copying exactly none of this down because this is bad. O, U, O, and then U gives me ooh, okay. And right. And whenever I hit a letter, right. Okay, and then whenever I get a vowel, right, I'm gonna want to do I want to basically syllables, the way they work is that they're only going to end with vowels. So whenever I hit a vowel, we'll add in the letter and then we'll do output plus equals the dash, right? Run, and we'll do aloha. Aloha. And I'm like, oh, hey, aloha. That's pretty good. Okay, we've got one too many dash. It's the fence posting problem again. We know how to handle the fence posting problem. We just simply chop off the last character. Run it again. Aloha. Nice. Run module. Keiki. And this is where we run into issues. Keiki. Where we run into modules. Oh, right. Those pesky double vowels. Right? I didn't want to think about them because they're the hardest. And so I'm going to think about that for last, right? That's where we made the mistake. You see, we left that hard part for last. Which is that. So now so here's like, okay, so if I'm going through and I'm going letter by letter, wait a second. Oh no. Now I have to go and think about the previous letter and like, oh, I have to modify that. figure out, wait, what the previous letter was if I do it like this. Does that make sense? Like if we do it like this, then you suddenly end up with this nasty nested thing where you have to figure out where everything is. Now, before we go on, there is a bit of an easier way to do this portion, which is the only bit that actually matters. So, from this bit. And that is that this is a dictionary. This is homework associated with dictionary, so we should use a dictionary. And that's where the vowels kind of come in. And the vowels is kind of where that comes in handy, right? We can do a, and what do I mean by that? A, ah. E, eh. I, colon, E, O, colon, O, U, colon, ooh. Okay. So now that we have this set up, actually all I have to do is can replace this with one line, which is pretty cool. I know I ask if the letter is in the vowels. If it is, output plus equals vowels letter plus a dash. Yeah, that works, believe it or not. Or it should. What did I do wrong? Output. Here we go. Draw line word to pronounce. Aloha, right? So that just shrunk that if else statement down into this. That's nice. Okay, that's pretty good. So the issue is that if we use this approach right over here, the issue is that we're going letter by letter. However, we have this issue of double vowels. And this is kind of your hint on what you need to do here, right? Double vowels like the EI in K key, which should be pronounced A, right? As opposed to be pronounced E, right? Should be K key. So we've got this pronounced text over here. Output is equal to this. And the issue is that in order to see if something is a double vowel, we kind of have to look at two characters at once, right? We have to look at the current character we're on, and then the way we wrote it, we can only look at the previous character, and that's a pain. Looking at the previous character is a pain. The only thing, so what we should do is look at this character and the next character, okay? And then advance the amount that rather than going one letter at a time, if we read two letters, we go forward two letters. So in reality, what we've done looks like this. Ugh, I'm sorry, I'm so gross today. I'm just, it's the pain of being sick. Okay. So rather than doing this, what we're going to do is we are going to do the completely different way of doing this. Index is equal to 0. Okay. And then while index is less than length of the text, right? While it's a valid index, what are we going to do? Well, my first suggestion is checking if something's a double vowel, because when we hit if we go letter by letter, which is what we want to do, as soon as we hit a vowel, we can't assume that it's just going to be able to translate from, take that vowel, like if we see an E, we can't just simply translate it into an eh. Instead, what we need to do is say, oh, do I need to turn that into is the next letter an I? If so, then I need to read both those letters at once. So if the text from the index, and then what you're going to use there is a slice. So I'm going to just put past there. Handle double vowels using slice. Otherwise, check if vowel. Otherwise, it's okay. All right. So if you're handling double, check if it's a double vowel. Check basically if this character, the current index we're on, plus the one in the next character is, yes, this is the part to copy down. You want to check if this character and the next character are going to be in the double vowels. If they are, go into the double vowels dictionary and get the pronunciation for it and advance the index by 2. Otherwise, check if your vowel is in the single vowels and advance by 1. Otherwise, it's a consonant, and we're including the apostrophe and the space in the consonants. Okay. In other words, and the reason they're a string as opposed to a dictionary is because of the consonant. If I get a P as our input, we're going to be getting a P as our output. We don't have a special way to pronunciate it, right? We've got an A and that goes to ah, but L just simply goes to the L in low. So that's what consonants do in this language. So, um, so if we so if we read 2 characters because the double vowels index gets incremented by 2, otherwise it's going to be incremented by 1. Okay. And believe it or not, that's it. It's actually fairly straightforward. It ends up being, if you do it correctly, it ends up being very few lines over there. And then at the very end, maybe you handle the whole V's, W's being pronounced as V's sometimes. Okay. But that can just simply be checked by, hey, having another if statement in here. If it's a consonant, is that a W? Okay. What was the previous letter? And then you can just simply say, and the previous and you can check there, because checking what the previous letter was when we were doing it earlier, that would have changed our output, right? The entire point of this exercise is that you can't just use the replace method in the string function, from the string function. That's what kind of makes it tricky. Okay. All right. I'm going to go ahead and I'll just dump this in chat, I guess. Let's see. Can I format it? Yeah, format it. How do I format? Do I get any formatting options or no? Whatever. Okay. Here you go. I was like, wait, I can format it. Can I make it monospace? No. Okay. All right. Give everybody a second to do stuff with that. Um, I'm gonna leave most of what we do for what I plan to do for Monday, but for Thursday, but I want to talk about the problems we're gonna start going over now. So with this, we get to start going out over one of my more interesting kind of problems, which are Monte Carlo approximations. Now those sound really scary, and I want to assure you they're not really. I know if you go and look it up, Monte Carlo approximations or whatnot. You'll get something, or Monte Carlo method. You're going to get some crazy math stuff, which looks scary. Or it doesn't actually look too scary until they start talking about Markov models and um but unlike most math problems, notice that it has like pseudocode and an algorithm in here, right? Um but mind you, once it starts showing once we start seeing Greek letters, we start getting stuff where mathematicians are just trying to haze people essentially. Um yeah. So as I'll explain on Thursday, the name comes from the Monte Carlo Casino in Monaco, where the primary developer of the uh, method was Stanislaw Ulam was inspired by his uncle's gambling habits. In fact, most of the study of the pre-studies of statistics, most of the basis for statistics came from gambling, right? History of statistics, right? Novel, yeah, novel needs actually more of the history of probability, technically. Um, probability, and we'll see like here, games of chance such as dice were played in ancient time, and Galileo also examined the problem of dice throws, knowing some numbers appear more likely as more combinations have them. And really a lot of it came out through gambling and stuff like that. Um, and one of the big things is the law of large numbers, okay, which is the average results from random samples will converge to their true value. So in other words, here, if you throw a six-sided die, right, on average, the idea here is that if you kind of do the math, right, we've got six sides. If we add them up and divide by six, we're going to get 3.5, right? So six, like, let's just do that now. 3, 4, 5, 6 plus 6 is 12. 12 plus 9 is 19. Divide by 6. 3.5. Do the math right. Yeah. Yeah. 1.5 left over. Divide by 6. 3.5. So we've got this. Oh, right. Because it's also off by 1 because we also are working in the range of 1. But the average result is going to be a 3 or 4, right? Right? The average result between a 1 and 7 is going to be 3.5. The average result between a 2 and a 5 is going to be a 3.5. The average result between a 3 and a 4 is going to be 3.5. The average is going to be over here. Okay. So you throw a lot of dice, it's not going to give, you're going to throw dice, and it's not going to always come up with that average result. But you come up with enough dice throws, it's going to converge to the now. Meaning that if you get enough samples of random samples, these random events, you're going to get something that approaches the actual mathematical truth. And what Monte Carlo approximations do is that they just simply extrapolate this to fun things, right? So let's go ahead and do I have a deck of cards here? All right. You know what? I'll make do. We have a I have a Wacom tab. So I'm going to leave you with a problem that we'll come back to in a bit. Okay. Now, programming wise, all we need to do these, what we really our main thing that we need for this a is the random function. Sure, it's because I'm just talking so much. Hi, Mer. You want to say hi to everybody? No, you just want to stay put. You're going to say hi to everybody. Say hi to Murphy. He's one of my three cats. She is extremely social when she's extremely social when there's people around. But technically you aren't around. You're just things on a screen which are very not interesting. So I've got three cats. And I used to have a dog, but she got very, very old, unfortunately. These cats, though, are 15 somehow. Somehow. And again, she's just very friendly. And she is a pain in my butt because she wakes me up at like 4:30 every evening to go and sorry, at 4:30 in the morning every day, just simply to say, "Hey, can you can you come and see the food bowl? I can see the bottom of the food bowl. Yes, there's still food in it, but I can see the bottom." Okay, there you go. Yep, you call on me. There you go. She was caught on me a bit. Yeah, except I don't want to get up at 4 in the morning. Okay, so there you go. Cat tax paid. Okay. All right. Now, let me go ahead and share my whiteboard. Okay. So this is the problem that we will come back to on Thursday, but I want to leave you with it, and so maybe you'll think about it. Okay. So a lot of these problems are basically bar game kind of things. Um, and let's go ahead and assume that you've got 7 cards, right? We've got 7 cards, normal playing cards. And what we've got is that we've got, let's go with, uh, yeah, let's go with 5 black cards, right? 5 black cards and 2 red cards. Okay. Like, and by red cards, I mean cards that are, cards that are diamonds, right? Versus cards that are, clubs and stuff like that, right? Different suits, right? Playing cards have different suits. So 5 black, 2 red. Doesn't matter what the values are. Okay. And what I'm going to do is I'm going to shuffle them up. I'm going to shuffle them up and and I'm going to lay them face down. Let's go ahead and use purple over here to indicate that these are face down and we don't know what they are. Because black would imply that it's something. So we've got 7 cards here. 7 cards total. 5 of them are black. 2 of them are blue. Sorry, 5 of them are black. 2 of them are red. And what my goal is, or what the goal I want for you is that I'll bet you maybe $5, okay? $5 bet that you will get $5 if you can successfully flip over 3 cards, right? 3 cards without any red cards. You win. But if you flip over any of those 2 red cards, you lose, and I get the money. I get $5 instead. You got to give me $5, right? So it's $5. So you get $5 if you win. I get $5 if you lose. All right. And honestly, this game is rigged in your favor, right? Because I would never play a game against you where uh you know you're a student. I wouldn't cheat you out of anything. Um, I mean, obviously it's in your favor because look at this, right? We've got Look how many black cards there are. There are 5 black cards, and there's 2 red cards. So that means, right, on our first flip of the cards, there's a 5 in 7 chance, right, that you don't hit anything. That's more than 50, right? That's a greater than 50% chance. In fact, the next flip of the card, right? Well, let's assume you don't flip anything over. That means that you've got a 4 in 6 chance of getting it right. And the next card, you've got a 3 in 5 chance of getting it right. 3 flips, each greater than 50% chance. I mean, that's pretty good odds for you, right? Right? So my question is, what are the actual odds of you winning this game? Now, there is a couple of things. Now, there's a couple of things that you'd be able to answer if you've taken a probability and statistics course, such as whether probabilities are independent or not. Independent, right? Independent probabilities or not, right? And the answer is that these are not independent probabilities, but I want you to think about that. How in the world would you figure out what the actual odds of this game are? And the answer is that you can mathematically figure out what the odds are of this game are. Pretty straight in a very straightforward manner once you know statistics and probability. In fact, if you're interested, take this problem to a math professor. I think they'll have a ball with it. You know, um, this is a game, but this is a not a fair game. It is rigged in my favor. Okay, now what we will do is that we're going to say that on Thursday though is that honestly doing the math is kind of hard because we may not know all the tricks that we need to do. So instead what we're going to do is actually write a computer program to play this game. And we'll count the number of times we win and we'll count the number of times we lose. Right? In fact, we don't even have to count the number of times we lose. We just have to count the number of times we win and the total number of times we play the game and present that as a fraction. And that will give us at least and if we do that enough times, if we do it like 1,000 games, which a computer can do just like that, no problem. That gives us the answer or something close enough. So that's our goal. We are that is what Monte Carlo approximations are. That is just simply we're going to simply we've been presented with a game, and all we're going to do is play the game rather than and count the number of times we win. That's it. That is all we are doing. Nothing more advanced than that. Yes, Monte Carlo approximations are and methods are great for doing, higher level math stuff. But honestly, when we get down to it, it's just simply here's a game or a of some kind. Let's run through it. Okay. So with that, I think that I have used up all of my energy. So with that, take care. I will post this recording when it is done rendering. All right. Yeah, I hope I feel better. If for some reason I am not, I will assume that we are doing Thursday. Okay, in person. All right. Thank you, Shalani. Send me an email. I will double check that. Um, if you need, just if you need me again, I'll have office hours Thursday, Wednesday evening. Send me an email if you need me, but assume that we'll be in person on Thursday. If that changes for some reason, I will let you know. This just simply seems like a nasty cold, but otherwise good. Raphael, yeah, I can take a minute. Hold on a second. Let me figure out. Um, 1 second. Be right back. Hey, Annie, are you gonna go pick up Laser? Okay. Yeah. Yeah, sure. You can talk if you wanted to talk about your final project. It can take a minute. Okay. Otherwise, yeah. Okay. If you have questions in general, you can hang out. I'm not going anywhere. Hey, turn on microphone. Will go quicker. All right. I can't hear you're currently muted.
All right, can you hear me
Yes, I
now?
can.
Okay. So, Tina and I, we just
Yeah.
wanted to tell you about like our idea for the final project.
Sounds
Um,
good.
yeah, I know you mentioned something about doing like visual novels,
Yeah.
and since we're both such avid like
Visual novelist, I guess.
visual novelists,
Yeah.
and yeah, we decided we're gonna do one of those, and
Yeah.
we're gonna do the art and music and everything. So
That sounds great.
yeah.
That sounds great. Any, I highly recommend just diving into Ren'Py, okay, for doing that kind of thing. Um,